quick video on section 10.2 to get you guys started. The key concepts from this section are the idea of a central angle and arcs, minor arcs, major arcs, semicircles that are created on the edges of the circle. So I have a diagram here with, call it circle C, since C is the center of that circle. The central angle is defined as ACB. We know how to name an angle. I'm starting at A, vertex of C, and ending at B, the other side of it. We could also name this angle BCA. I'm giving that a measure of 50 degrees, and I'm also giving it an associated arc measure of 50 degrees. The central angle has to have a vertex at the center of the circle, and its measure is going to be exactly the same as the arc. So since the central angle is 50 degrees, the arc is also going to be 50 degrees. We've named that arc AB. It only needs to be named with 2 points. It's called a minor arc when it's less than 180 degrees. So this can be 10 degrees, it can be 50 degrees, it can be 179 degrees. If it's less than 180, it's called a minor arc. The key point here, if it's just 2 points, if you have an arc that's just 2 points, the assumption is that you're going to take the shortest possible path to get from point A to point B. So you're going to go from A to B if it's just named AB. You would not take the counterclockwise approach going back this way. If I did that, it would be called a major arc. Since a minor arc is less than 180 degrees, a major arc has to be greater than 180 degrees. You see that the major arc is specified by including a D in between A and B. I've called this major arc ADB. So I have to start at point A, I have to pass through D on my way to get to B. Let's define the measure of this major arc. Since the only remaining arc measure, if I go from point A to point D to point B, is the 50-degree minor arc, this major arc is going to be measured at 310 degrees. Just subtract 50 degrees from the full measure of the circle, 360 degrees. Let's define one more arc that we see in this diagram right here after I talk about semicircles. A semicircle is going to be exactly half the circle based on semi, so that's 180 degrees. We could name this, in this circle, we see a diameter of AD passing through the center C, so we could name this semicircle AD, going counterclockwise, or if it says ABD, we could go clockwise, starting at A, passing through B on its way to D. So each of those arcs are going to have a measure of exactly 180 degrees. So if that's the case, let's practice and find the measure of the arc DB. The measure of the arc DB. So like I was saying before, if it says DB, only 2 letters, your assumption is going to be take the most direct path. So go directly from D to B. Since we defined AD as a diameter, cutting it into 2 arcs, 2 semicircles, and this piece of this side of the circle is already 50, we can subtract 50 from 180 to see that this measure is going to be 130 degrees. One more concept I want to introduce is the arc addition postulate. Very similar to the angle addition postulate, the segment addition postulate you learned earlier this year. Let me create one more radius in this circle. We'll make it radius CE, and I'm going to give that a measure of, let's make it 80 degrees. So if I make that measure 80 degrees, then let's say I want to find the measure of the arc AE. Once again, if it's just 2 letters, I'm going to take the most direct path from A to get to E. So I'll add up the central angle 50 and the central angle 80. Therefore, the measure of my arc from A to E is also going to be 130 degrees. I'll end up with the same amount there coincidentally, but that's a little starter for 10.2.